Okay, we're going to now discuss precision and accuracy as we're taking these measurements. Okay, measurements in science need to be both precise and accurate. Now you may not know what each of these words mean, so we're going to go ahead and define them. Precision is how close together the measured values are to each other. Okay, so how close they are to each other. So you're looking for a grouping of numbers that are right around the same number. Okay, so now that we've discussed what is more precise, look at these two targets here. Which one would you consider to be more precise? If I told you that precise is how close they are together, which one is more precise? Correct. You should have said the one on the left is more precise and the one on the right is less precise. Precision can also be which one has the most decimal places. So keeping that in mind, go ahead and look at the question there in your notes. What is the most precise measurement for the liquid in the graduated cylinder to the right of that question? Okay, I want you to look at your options and select which answer is most precise using the rule that it has the most decimals. Okay, you should have selected B. B has the most decimal places, therefore it is the most precise answer. Okay, next for precision, the smaller the units or the increments on the tool means the more precise they are. So if we're using a meter stick has meters labeled, centimeters, and millimeters labeled. Measuring in millimeters is much more precise than measuring in whole meters. So if I was going to measure the length of the table, I could use the whole entire meter stick and say that this table is a little over 1 meter stick long. That's not very precise. If I use millimeters and said that the table is 156 millimeters wide, then that would be the most precise measurement for that table. So looking at the question there in your notes, which graduated cylinder is the most precise? Take a second, look at your options, and then circle your answer. Come back to the video. Okay, you should have circled A. Now when you are looking at this, you need to look at multiple things. First off, we've said that the smaller the increments, the more precise. Now just because these little tick marks here are smaller doesn't mean that the increments are smaller. Okay, so look, this one jumped by 10 and this one jumped by 10. So between these two, yes, each of these little things right here makes it more precise. But the difference between this one and this one is that here we're going 10 units, and on this one we're jumping 1 unit. So each increment here is 1/10 of a unit. This one is 1 unit. If this is confusing to you, take a second, pause the video, look at each of these numbers very carefully and think what each tick mark really stands for. Even write little data next to each one. So this would be 10, this one would be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You should end on the same number. If I counted that way here, I'd go 5, 6, 7, 8, 9, 10. You see, we're already going too far. Because if I'm at 10 here and 6 is here, that doesn't make any sense. Instead, if I say 5.0, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6.0. Do you see we're at 6? So each of these little tick marks means that this is a more precise tool. Okay, so last thing for precision is how close the numbers are to each other. So if the groups of measurements are close to each other, like in example 1, 5.4, 5.3, 5.2, they are called precise. In example 2, 5.1, 5.9, and 5.7, these aren't very closely grouped together. There's a big space. Do you see we've got 0.8 between these two? They are not as precise as the first group. Now that we've discussed precision, now we're going to talk about accuracy. Accuracy is how close a measured value is to the actual value. So for example, the actual mass of substance A is 22 grams. 3 students each took the mass of the substance. Jerome found 21.9 grams, Ashley 21.7 grams, and Nick 22.4 grams. Which student would you consider most accurate and why? Go ahead and pause the video, fill in your answer, and come back to the video when you're done. Okay, you should have said that Jerome was the most accurate because he was the closest to the actual value. Jerome was 21.9 grams. That was 0.1 grams away from the actual mass of substance A, which is 22. So let's look at these 3 targets listed here. Here we have good accuracy because someone got within the target, but we have very bad precision because they're scattered everywhere. Remember, precision was grouped close together, accurate was closest to the value. Here, no one hit the target, so we have poor accuracy. But all of the arrows are close together, so we have good precision. This is what we're striving for in all of our scientific measurements. We have good accuracy, everyone hit the target, and we have good precision because they're all grouped together. Okay, so let's look at the question. The length of a pencil was measured by 3 students. The actual length of the pencil is 13 centimeters. Student A found 13.2 centimeters. Student B, 12.55 centimeters. And student C, 12 centimeters. The first question asks, which of the measurements is most precise? So go ahead and guess your answer, write it down, and come back to the video. Okay, you should have selected that student B was the most precise. Remember, precision is not just grouping together, it's who has the most decimal places. Student B had 2 decimal places by saying 12.55, so they are the most precise. Next, which is the most accurate measurement? Pause the video and come back to it when you have put an answer. You should have selected student A as being the most accurate. The actual length of the pencil was 13 centimeters and student A wrote 13.2. That is closest to 13. Let's answer the next practice question. Each of 5 students used the same ruler to measure the length of the same pencil. These data resulted 15.33 centimeters, 15.34 centimeters, 15.33 centimeters, 15.33 centimeters, and 15.34 centimeters. The actual length of the pencil was 15.85 centimeters. Describe whether accuracy and precision are each good or poor for these measurements. So look at the entire data that has been given and tell me, was precision good or bad? Was accuracy good or bad? Write down your answers, then come back to the video. You should have said that students were very precise because all of their measurements were close together. All of them were within 1/10 of each other, many of which got the same answer. So they are precise. The students were accurate because their measurements were close to the actual value. You could have argued either way on this. I would have said that it was less accurate than could have been, but they were still within reason to be accurate. If you wrote that they were not very accurate, that's okay. Keep your answer. As long as you can explain why you said that, that's all that matters. Next, measuring the volume of a liquid. Which of the containers would give the most precise measurement for the volume of a liquid, and why? Go ahead and pause your video, answer, remember to tell me why you chose that answer. Okay, you should have said that container C because it has the smallest increments. If you notice, each large tick mark jumps by 10. Each large tick mark here jumps by 20. The test tube has no tick marks except for 10 milliliters up here. And this one, each tick mark jumps by 100. This is the most precise tool for measuring volume. Precise and accurate measurements mean that the data are reliable and can be assumed to be real. Other scientists use your information as background information for their own experiments. The public depends on the most accurate information to make decisions. As long as your measurements that you take in your science lab are both precise and accurate, then you have done the best job you can.